In this video, I want to give you some additional graphing tips and also help you figure out how to determine the best fit line for a scatter plot. This data was made using a GC mass spec, which is an instrument that uses gas chromatography with the detector of a mass spectrometer. And so that instrument is able to tell basically how many ions hit at any given moment of time. And so you'll end up having, as your data will have peaks that will correspond to different analytes or different species in your sample. So in this case, we have caffeine that we're testing with this instrument, and you might have smaller peaks for smaller concentrations of caffeine and larger peaks for larger concentrations. And that's exactly what our data looks like right here. And so what we did was we injected different concentrations of caffeine standards into the instrument and then saw different sizes of peaks. And these peak areas, this is just the area under the curve of the peak that was established, and we have numerical data for all of these things. And so what we want to do is we want to just use this data and see if we can't use the caffeine peak area to determine the concentration of caffeine in an unknown solution. And so in order to do that, we would determine the best fit line for a scatter plot and then use that y equals mx plus b formula to figure out what that concentration of caffeine is in our unknown. Alright, so we have a graph here. This is a graph that's similar to the last video. We made it the same way. It's a scatter plot, but I want to show you a little bit of tips because right now I already have my axes labeled, and before we double clicked and then we typed in here into the title here. But instead, let me do something else. If you click up here in this function toolbar, this little area here, and you just type in equals, and then this is our y-axis, so I just click here. Watch what happens when I hit enter. It automatically changes the title to there. And I can do the same thing. I can type equals and then just click on my y-axis, and when I hit enter, it appears. And that way, if I ever change it here, sometimes it's easier to change the font here, it'll automatically change it here. So say I say let's use height instead, it'll change the axes immediately to correlate with my cell. And I can do the same thing for the title. Just hit equals and then choose my cell that contains my title, and now I have my curve line here. Okay, so I've got my graph set up the way I want it. Now in order to hit enter a best fit line, you're going to right click on the data points and click add trend line. That is the best fit line to match your data. So now what does the equation for this line look like? And it looks like this. Let me make it black and make it a little bigger so you can see it a little better. And so what we're looking at here is this is in the formula y equals m, where m is your slope, x plus b. So our b, or our intercept, is a negative number in this case. And this r squared value is 0.9986. Something to notice here is this 0.9986 value. It does not mean that my data is really, really good and amazing. Instead, it says how well does my data match a line, not how good is my data. And there is some distinctions there between those two things. I have had before beautiful r-squared values, 0.9999, and had terrible data, data that scientifically made no sense. And so it's possible to have that. But in this case, if my data makes sense and I have a good line, that is a good sign. So that is your best fit line. Alternatively, if I just wanted to find my slope, because see that doesn't have a lot of data points in it, right? So I could say turn this into a number, and now I've got all of the data there. Or maybe I just want it in scientific notation, but instead of just having 1 decimal or no decimal in this case, I could tell it to give me more decimals. I can change it here under number, and then I can change how many decimals are displayed for me. And I can do that same thing here with my axes. So this one looks pretty good to me, but I want this to be in scientific. It's the same thing where you go to your axes options, number, and then choose scientific. And now it's going to put that into scientific notation for me. There's also another way of doing it, is I can determine my slope and my intercept within Excel, within an actual cell. And so in order to do that, you just type in equals slope. Notice how whenever you type in slope, it's going to show you that you need to choose your known y's and then choose your known x's. So in this case, these are my known y's in my calibration line, and these are my known x's. And you just hit enter, and notice how this slope here is the same as this slope here. Now I could make it look the same by just choosing scientific notation. And then same thing for this value, we'll choose scientific. All right, and then for intercept, you do the same thing. What do you think our formula is going to be? Intercept, and see how it appears. And now we know known y's, comma, known x's. So we're just doing what the formula prompt tells us we need to do. And now see how it matches up here. Okay, so why that's important is, let's say our unknown has a peak area of maybe like 1,500,000. Okay, and let's put some commas in there so we can see that does kind of match. So we know its area, its concentration is probably a little bigger than this and a little less than that. And so, but what is it? What is the concentration? That is our question. So remember, our unknown peak area that's a y value. So when we're asking for concentration, we're trying to solve for x. So if we have y equals mx plus b, in order to solve for x, we essentially have y minus b divided by m. Or in our case, we have y minus our intercept. Sometimes it's just helpful to kind of put it out in words like this. Y minus our intercept divided by our slope. Well, now in this case, we already have our slope and intercept in numbers, so we don't have to retype it in from this. And if we just use these cells, then we can, instead of rounding, we're getting very exact numbers. So my concentration is going to equal, parentheses, my y value minus my intercept, in parentheses, divided by my slope. And then if we put that into scientific, we will see that it's right in the order of magnitude that we would expect it to be. And that is my final answer. That would be my concentration. And so with this video, you figured out how to determine a best fit line for a scatter plot, and then just some other graphing tips that might be helpful to you in the future.